Hello everyone. In this video I'm going to go over some homework on normal percentiles and normal percentile ranks. So in other words, we're going to find percentiles and percentile ranks for variables that are normally distributed. So you're going to need either a calculator or your standard normal distribution table, that is this thingy, to look up areas associated with certain z-scores. Just to remind you, the CDF here, that stands for the cumulative distribution function. That is the function whose values are given in this table. So its function name is the CDF, and when you plug in a z-score to it, the value that you get out is whatever value you're grabbing from the table here. Okay, so let's look at the first question. According to the class survey data, the mean height of Dr. Jensen's stat students in inches is 68.4 with a standard deviation of 4.3. Assuming the data are normally distributed, what is the percentile rank of someone who is 5'6"? So in order to figure this out, because we're doing normal distribution, we need to convert data values into z-scores. So I'm going to take this data value. First, I need to express it as total inches, like the mean is given here. So my x value, my data value, is going to be 5 times 12 plus 6. That's 5 feet plus 6 more inches, 66 inches. All right, and now I'm going to calculate the z-score. So if you don't have this memorized yet, it is the data value minus the mean. So how far the data is above the mean, and then you figure out how many standard deviations that is. To do that, you divide by sigma. So remember, z is the number of standard deviations above the mean that the data value lies. This one is actually going to be below the mean, so it's going to turn out to be negative. And I know that because 66 is less than 68.4. But we're still going to calculate it the same way, and it'll just turn out that it happens to be negative. So you need a calculator for these questions. You need to actually find out what these numbers really are. I'm going to round to 2 decimal places because I'm using my 1800s style table here to avoid needing students to buy a particular calculator. I let them use this table instead. Any graphing calculator does have this function in it, though. It's called usually just called normal CDF. So you can probably find that in your calculator somewhere. So negative 0.56 if I round to 2 places. Negative 0.56. Okay, so that is the z-score of this person's height. And now I want to know their percentile rank. The percentile rank is the percentage of people that are shorter than them. Okay, so percentile rank is percent of data that are less than this data. All right, so that is what we're trying to find. It's just phrased differently. And we already know how to do that from previous homeworks and lessons. So we just look up that z-score in the table here, and that is exactly the percent of the data that should be less than that z-score. So we're looking for negative 0.5. And let's see, it goes from the left. This is negative 0.50, 0.51, 0.52, 0.53, 0.54, 0.55, and this one should be 0.56. Let me make sure. Yep, there's the 6. So 0.2877. So the correct notation here is, please, for the love of God, do not write this. This makes me feel like ants are crawling under my skin when you say the 2 numbers are equal to each other like this that are not equal. As a mathematician, this is like spitting in the eye of God or something. Like, how dare you say that these numbers are equal? Please don't say that. If you must say it in some really undetailed way, you could maybe put like a little arrow or something, but I really wish that you would just give in to calling this the CDF of the z value. So this is the CDF of this z value, cumulative distribution function, 2877. And why is it called the cumulative distribution function? Because here is the distribution right here. That's this shape of how the histogram looks for normally distributed data. And you are accumulating all the area from negative infinity over to the z-score that you're interested in. So you're accumulating all that area from as far left as you can go up to the z-score. So that is why it is called that. And then it's a function because we put numbers in and we get numbers out. That's a function. Okay, anyway, sorry to just suddenly scold you in a YouTube video. I am a teacher though. Right, so that is in fact the percentile rank. So the percentile rank here is answer. Percentile rank is 28.77, and you can write that as percent, or sometimes people just write it as a number like that. To me, I think it makes more sense if I leave the percent on there so I can think more clearly about what this is. Okay, now what is your percentile rank? So maybe I'll do this from my dad instead of me, because I'm always having to admit how short I am. My dad was really tall, so I'm going to do my dad's percentile rank. Okay, so X is going to be, he was 6'4", so 12 inches times 6 feet plus 4 more inches. So that's 72 plus 4, that's 76 inches for my X data value. Now I'm going to convert that to a z-score. Of course, he wasn't in my stats class, so his data value shouldn't be in this set, but oh well. We're going to do this anyway. So 76 minus the mean, which was 68.4. Right? Yeah, 68.4, and then the standard deviation was 4.3, and that's going to be approximately 68.4 divided by 3. Yes, a nice high z value, so I can feel a little taller about myself. 1.77. Okay. So now I'm just going to do exactly what I did before. I'm getting the CDF, because that's going to tell me what percentage of stat students would be shorter than that, and that is the same as percentile rank. It's the percentage of the way through the sorted data set that this height would be. So 1.77, let's turn to the positive side here. 1.7, 0, 1, 2, 3, 4, 5, 6, 7 should be this one. 9616, 9616. Okay. So that is 96.16%, and that is the answer. This is the answer. Okay, 96.16% of the way through the sorted list of heights would be where my dad is. He was really tall, so he would be right near the end of the list. Okay, so now we're going to go the other way around and find percentiles. So percentile ranks are percentages that represent how far through a list of sorted data a certain value would be. Percentiles are the data values that would be this percentage of the way through the list. So the 10th percentile is the data value that would be 10% of the way through that sorted list. So this, if it's applying to someone's height, that person's pretty short. Like I might be in the 10th percentile. I'm only 5'3". I think I'm around there somewhere. 85th percentile, that's going to be somebody who's really tall. Not quite as tall as my dad. And 99.5th, they must be even taller than my dad. Okay, so these are going to be heights. These are data values. And these numbers that we put the little th next to, those are the percentage of the way through the sorted list of data that the data values will be. Okay, so how do we figure this out? The 10th percentile. So I'm going backwards. I have this percentage part here, and I'm trying to go backwards and see what was the z-value that produced that percentage. And then once I have that z-value, I'm going to keep going backwards, and I'm going to go all the way back to x. What was the x value that gave me that z-value? Okay, so I need to know what z gives me CDF of z equals 0.1000, as close as possible. What z-value gives me 10% of the area is to its left under the standard normal curve. So I'm going to look in my table here, and I'm going to use it backwards. Let's see, how do I... Okay, I erased my old highlights here. So I'm looking for 10% area in this big part of the table, and then I'm going to see what z-value that corresponds to. So I'm going to try to get as close to 10% as possible. I know I'm not going to hit it exactly. So 10% would be between these two values here, and then you can see which one is closer. 10.03 here, that's a little bit closer than the 985 here. Okay, this is the 10,000th place at the end, so 0.0985, that is 15 10,000ths away from 0.1, and 0.1003, that is 3 10,000ths away from 0.1. So that one is a little bit closer, and the z-score I'm looking at for that is negative 1.28. So negative 1.28. after you've done these percentage questions for a while, you'll start realizing like, oh, I've looked up that value before. You start looking up the same ones like over and over again. Okay, so z equals negative 1.28 is the closest. If we had an actual computer or a calculator, you can do the inverse normal CDF function and get a much more close answer, but this is fine. This is good enough. All right. Oh, sorry, this should go down here. Okay, so that's the closest z that gives me 0.1000 for my CDF. Now I just need to translate z back into a data value. Translate z into a data value x. And you know what? There is a formula for doing this. Sometimes I'll see people will use this formula, and maybe they do this because this is the only one they have memorized. They'll use this formula, and then they'll plug in the z over here, and then they'll solve for x. And it's just a linear equation, so you can solve it in like 2 steps. But you don't even need 2 steps because there is another formula that is already solved for x. So if you multiply both sides of this equation by sigma, you get sigma over here, sigma over here. These sigmas cancel out on the top and the bottom here. So on this side, you just get x minus mu. Then you add mu to both sides. Now look what you're looking at here, guys. I add mu to both sides. So this one goes away. Look at this. This is our x formula. That's the reason there's 2 versions of this formula, because this one's pre-solved for you. We usually write it in the other order, right? We put x over here. So you don't have to solve for x from the other equation for z. This version of the formula exists exactly so that you don't have to do that. You can just plug in z and sigma and mu, and you get your data value. Okay? All right, but you can do it the other way. It's fine if it's more fun for you. Sometimes my cat likes to lie upside down and eat from his food bowl like that because it's more exciting. So if it's more exciting, you can do it that way. All right, 68.4 was the mean. Our z value that we just found was negative 1.28. And sigma was, I already forgot, 4.3. Okay, so we just put that in a calculator. Be a little bit careful if you're using a for function because the order of operations is multiplication should be first. If you type it from left to right, you might do the wrong order of operations. So I'm going to actually do 1.28 negative key times 4.3. So I'm going to do that part first, and then I'll add 68.4 to that. Okay, so I'm getting 62 let me round to one place, 62.9, because these are, this number and this number are rounded to one place, so I'll just match that. All right, so that is the height that I'm getting for the 10th percentile. Now, does this make sense as a height? 10th percentile should be only 10% of the way through the sorted list of heights, so that person should be pretty short. And how tall is this person? 5'3". Oh no, that's me. Yep, it's me. I'm in the 10th percentile. Oh well. All right, now let's do the 85th percentile. So this person should be pretty tall, not as tall as my dad, but a lot taller than me. Probably because we have the men and the women mixed together in this problem. All right, so what is the 85th percentile? So again, we need to figure out what z gives me closest to 0.8500 area to its left, or in other words, the CDF value of 0.8500. So I'm going to come in my table here, looking at these values in the table, not at z along the edge, 8500. So it's between these two, and I see the second one is a little bit closer. So I'm going to go with 1.04. So 1.04, not 1.4. 1.4 would be down here. 1.04. Okay, and it makes sense that this should be a positive z because 85th percentile is past the mean. In the normal distribution, the mean and the median are exactly the same, so the 50th percentile is the mean. And we've gone past it to 85th percentile, so we should have a positive z value. Okay, now I just need to translate this back to a data value using this formula. So 68.4. Once you get used to doing these, they're not too bad. And I'll put that in a calculator. I'm getting 72.9, which is about 6 foot, a little bit less than an inch, so almost 6'1". So that makes sense. It's pretty tall, taller than most people, but not as tall as my dad because he had this percentage rank, or percentile rank. Okay, so last question in this part, what is the 99.5th percentile? So same way, what is the z that has CDF of z equals 0.9950? So we're looking for that in the table. 9950 should be pretty far along. Oh, I see here it's exactly between these two. Since it's straight dead between them, you could average those z-scores together, go halfway between them, or I could just pick one. I kind of don't really care which you do. I'm just going to pick one. 2.57. If you were really doing this for some real world problem, you would use a computer to get a much closer z-score anyway. So I'll go with 2.57. All right, and now we turn that back into a data value from a z-score to a data value. 68.4 plus 2.57 times 4.3. Okay, put that in a calculator. I'm getting 79.5, which is 6'7.5". So yeah, really tall. Taller than my dad. All right. Next set of questions are pretty much exactly the same as the first set, just giving you a chance to practice it again. So let's practice again. According to the class survey data, the mean time that Dr. Jensen's stat students spend watching videos per day is 167 minutes, like almost 3 hours, with a standard deviation of 117 minutes. Really large standard deviation, so a lot of variation. Assuming the data are normally distributed, what is the percentile rank of a student who spends 60 minutes per day watching videos? So it's really important that we actually have this phrase here, assuming the data are normally distributed. That's what allows us to use this table here to answer the question. If we didn't have that information, this question would not be possible to answer because we wouldn't know what type of shape the histogram would look like, and we wouldn't know how to find the areas under that curve. Okay, so since this is a normal distribution question, what is the percentile rank of a student who spends 60 minutes per day watching videos? So this 60 minutes per day, that is my x, my data value. And since it's a normal distribution question, usually when you have a data value, translate it into a z-score, or if you have a z-score, translate it into a data value, one way or the other. So I'm going to do x minus mu over sigma. Oops. Okay, so 60 minus, let's see, the mean was 167. Sigma was 117. All right, I'm going to put this in a calculator. Oops. I'm getting negative 0.91. Right, and now I'm going to look that up in my table. I'm going to look it up the normal way, not the reverse way. So, okay, I'm on the negative side, negative 0.9, and then this should be 0, 1. Yes, so negative 0.91, 1814, 1814. Okay, so this is 18.14%, and that is the percentage of the way through the sorted list that the student's data value would be. 18.14% of the way through the list. Okay, what is my percentile rank? Ooh, how much time do I spend watching videos? I have severe ADHD, and I actually find videos to be really boring. Like, I have a lot of trouble paying attention to them. I need something more stimulating than that. If you ask me how much time I play video games, that would be probably a couple hours, but videos, just videos, maybe if I include cutscenes, let's go with like 30 minutes, probably at most. Okay, so that's my data value. Opinions may differ amongst yourselves. I'm going to go ahead and put this into the z-score formula here. Let's see what my z-score is. I think it's going to be really negative. So negative 1.17. Okay, and I'm going to my CDF table. That's why I like math, actually. It's because it occupies my whole brain. I love that. Negative 1.17. So 1, 0, 1, 2, 3, 4, 5, 6, 7. Actually, a lot of people with ADHD like math for the same reason. So 0.1210. 1210. Okay. So if we sort the list of video watching times from least to greatest, I am 12.1% of the way along the list. So a few people watch less than me, but not that many. The last three here, what are the 25th, 60th, and 98th percentiles? So for these, we're starting with the area or the CDF value, and then we are looking up the z-score. So it's that reverse lookup process. So we want z with CDF of z being 0.2500. Okay, so let's go to the table, see which z gives us 25% of the area. Looks like it's between these two. And I think 2514 is slightly closer, so I'm going to go with negative 0.67. Negative 0.67. Does that sound familiar? After looking these up a few times, you start to see the same ones over and over again. Okay, and then I'm going to take that z-score and I'm going to convert it to a data value using this formula, z sigma. So data value is located at the mean, and then you go up by this many sigmas, this many standard deviations, z standard deviations. That's what z is. It's the number of standard deviations that you are above the mean. And that's what this formula is literally saying. Okay, so 167 plus negative 0.67 times 117. Put that in a calculator. I'm getting 88.6. That kind of makes sense because 60 minutes was 18%. So a little bit more than that, 88.6 minutes is 25%. Yeah, makes sense. 60th percentile, I can already tell these two are going to be above the mean, so they'll be above 167. 60th percentile shouldn't be too far above. 98th is probably pretty far above. Okay, so same procedure here. I want z with CDF of z being as close to 0.6 as possible. So I'm going to look in the table, reverse lookup. Where do I see an area of 0.6? Between these two. And let's see, this one is 13 10,000ths away. This one is 26 10,000ths away. So I think 0.25 is going to be the closest. 0.25. Right, now I convert the z-score into a data value with the formula mu plus z sigma. 167 plus 0.25 times 117. I'm getting 196.3. Last question, what is the 98th percentile? So I want z with the CDF value, the area under the curve to its left, being as close to 0.98 as possible. Another reverse lookup, 0.98. Between these two. The first one's a little bit closer, so this will be 2.05. 2.05. 2.05. Okay, and now I have the z-score. I can convert that to a data value with this formula. So I start at the mean, and I go up z standard deviations, 2.5, 7, and put that in a calculator. And I'm getting 406.9. That's a lot of minutes to spend watching videos. All right, so that is it for this homework. And if you have any questions, send me an email. Otherwise, I will see you in class.